go.
Here we are back at CTCS in the chemistry department. We're going to solve problem number 21, which I have written down on the board behind me. So what we're essentially working toward is solving problem 22 eventually. So we're going to essentially solve for molarity, molality, and percent composition. Okay. So this one, you're actually given a percent of hydrogen peroxide, and in parentheses afterwards, it says M/V. The M/V stands for the grams or the mass per volume. Okay, so that's important to note. In problem 22, you're going to be using a mass calculation for your percent. Okay, so in this problem, it's actually pretty straightforward. It talks about hydrogen peroxide. It's often sold commercially, which you know. It's sold at a 3% or 3.0% mass to volume ratio. So in solving this problem, the first thing that you have to do is understand what that physically means. What this means, a percentage of anything, in this case, 3.0%, basically tells me that I have 3.0 grams of H2O2 per every, and the volume would be 100 milliliters. So you need in your head to understand that 3% solution, mass per volume, is that. Okay? It will really help you solve this problem. So we're looking, it says, if you buy a 250 milliliter bottle of this 3.0 mass to volume solution, it says how many grams of H2O2 have you purchased? Okay? And understanding just that from this, you should easily be able to solve the problem. So you're given 250 milliliters of that. So the units are right here. And so we want to know how much is in 250 milliliters. Okay, so in essence, all we have to do is multiply 250 milliliters times this, which the units cancel, leaving me now with grams. So my answer is going to be 3.0 divided by 100 times 250, and that gives me 7.5 grams of H2O2. So that's what you're paying for in the store, a 3% solution of that. Okay, so that's the first part. Okay, very simple to solve. The next part says, what is the molarity, that's big M, of this solution? Again, molarity, to understand this, you need to basically understand that you have the 3.0 grams of this material. Okay, so now we're going to split each one of these parts up in order to understand what we're dealing with. We're going to take the first top part of this, and we're going to essentially use that, and we're going to take the bottom part of this, and we're going to use that to determine the part of big M that we have to solve this problem. Remember, big M, molarity, is equal to, by definition, moles per liter. So I have, from this, I have both parts that I need in order to solve this. They just don't happen to be in the right form. Okay? So I'm going to take the gram part, and I'm going to take the 100 milliliter part, and each individually, I'm going to convert them to the things that I need to solve for molarity. So here we go. I have grams of H2O2. So what I'm going to do is use the molar mass of H2O2. And calculating that, it's 34.02 grams for every 1 mole. And so I calculated that, of course, by taking 2 times the molar mass of hydrogen and 2 times the molar mass of oxygen, added those values together and got the molar mass of that material. And then I did a molar mass conversion like we've been doing for the last 3 or 4 chapters, and I'm solving this problem to determine the moles. My answer comes out to be 0.088 moles. So that's the top part that needs to go into the solving of my molarity equation. The bottom part can be found here, okay? And I have 100 milliliters in this sample, but I don't want it in milliliters, I want it in liters. So again, that's pretty simple. All I have to do is to take, for every 1,000 milliliters, there's 1 liter. So again, all I have to do is to work this over the 3 decimal places, and of course that gives me 0.100 liters. So there's my second part of solving for molarity. And so here I go. 0.088 moles divided by 0.100 liters, and of course this is H2O2. And dividing these two will give you my final answer, which comes out to be 0.88 molar solution.